Hey guys, double check for 7.2. I'm going through just the odds since a lot of these are similar, so hopefully by going through some of these and double checking your work, and then you'll be good to go for the other ones. Number one, fairly basic. Again, remember you do need to write the first step as being one side. So in this case is that, and you do not put equal signs in here, okay? You do not say this is equal to like 1 over cosecant or cosine or something like that. It's not, the statement that you have here is not true. You're trying to prove that. We'll change tangent into sine over cosine, times change secant into 1 over sine theta, at which case these things divide out. That's going to equal 1 over cosine theta. That equals secant theta, and you're done. Okay, pretty basic. That's just again to kind of get you warmed up. On this one, I would recommend doing the distribution first. Do not, now notice it's not adding there, it's multiplying. So you do not FOIL this, or you do distribute it, but it's not a double distribution. And again, as I said before, do the algebra first before you worried about changing everything in terms of sine and cosine, because that's going to keep everything, I think, a little bit easier to deal with. So I'm going to distribute, before I forget, this goes to the tangent and to the cotangent. So then you can get sine theta, cosine theta, times cotangent theta. So sine theta times cosine theta times tangent becomes sine over cosine. Cotangent cosine theta over sine theta, in which case now things divide out. Here the sines are going to divide out because it's all multiplying. Here the cosines are going to divide out because it's all multiplying. So you get sine squared theta plus cosine squared theta. Remember, the squaring is not on the theta, it's on the trig functions itself, and that's going to equal 1 by the Pythagorean identity. That one's done. Problem 5. This one you just multiply out, okay? Double distribute everything, and this is going to actually end up being secant squared theta minus 1. Oops, Mr. Hayes, you just broke your rule right at the first step. So, I have secant theta plus 1 times the quantity secant theta minus 1. That's going to equal, by the time we distribute this out, secant squared theta minus 1. Because again, remember, when I hit the outer and the inner, I get secant theta minus secant theta. And that by Pythagorean identity is equal to tangent squared theta. So that falls apart. Sorry, I just dropped the microphone. All right. This one, a couple of different options. If you play with, oftentimes what I would suggest doing is that if you have two terms like I do over here on the left, okay, it's more beneficial or easier to turn two terms into one and have it go in the right direction than trying to turn one term into two. So I would start here. Second step, since there's no algebra to do yet, we're going to change everything into sine and cosine. Now here's the tip-off, well, two tip-offs that you need to combine these. You can either say, well, I know that I've got sine and cosine up here. Oops, where do I want to go? I've got sine and cosine up here in the denominator. And so I got a cosine in one denominator, a sine in one denominator down here in the bottom, so that would be the way to go. Or you can just say I need to combine two terms into one, so the common denominator is going to be sine and cosine. So that's going to end up equaling over sine theta, cosine theta is your new denominator, and then I've got sine squared theta plus cosine squared theta, and that's going to equal 1 over sine theta, cosine theta, and then we're done. And again, notice the only equal signs that I'm using are to link one step to the next, not saying I'm not going one line to the next like you would with a regular equation. All right, this was a little more involved. Now, you could try to, well, I'll maybe kick this out a couple of different ways. So first things first, you would say, okay, let's start with the left side. Following Mr. Hayes, well, let's turn two things into one. So since it doesn't really lend itself outside of, there's nothing really math-wise to do, change everything in terms of sine and cosine. So you can do that. The common denominator is needed. So multiply this by cosine over cosine. So now I've got cosine theta minus sine squared, or sine theta over cosine theta. And you'd be done that way. Or you could have done this side, which some people would see, because again, you see that cosine theta over cosine theta, and that kind of lends itself to become 1. And essentially, you're just going to work this backwards then. So you can write that as two separate fractions with cosine theta as your denominator. So then that's going to become 1 minus tangent theta. So that would also be a way to work. 11, same idea. If I'm going to start over here on the left, and this also may be one where you get kind of stuck halfway and you end up working both sides, and I'll show you how to do that potentially. And you're like, okay, so I've got that. I'm going to write that in terms of sine and cosine. So I get cosine squared theta minus 1 over sine squared theta. And then you're like, okay, well, if I do a common denominator, I could kind of play around with that. Maybe you get stuck. So let's pretend you get stuck. And then what I would do is draw a line in the middle and say, okay, I'm going to look over here on the left-hand side for a little bit. And see if I can get something that looks kind of like the cosine squared theta over sine squared theta. Or 1 over cosine squared theta minus 1 over sine squared theta. So I have this. I'm going to break this up into two separate fractions with the same denominator because that's what you can do with fractions. Okay. Now, change the tangent and sine cosine, or sines and cosines. So this is going to go here. And I'm going to essentially just slide this over and go like this. Oops, forgot the cosine. And then the same thing here. The cotangent is going to turn into cosine over sine. And then at that point, you can say, okay, these sines divide out. So I've got 1 over cosine squared theta minus, and then these cosines will divide out, and I have 1 minus sine squared theta. And you're like, wait a second, I think that looks familiar. So then you can kind of put an arrow and go over like this, or vice versa. And since you've got the same steps on both sides, then you can say, okay, I'm done. Because now you've got the giant transitive step, essentially saying that secant squared minus cosecant squared is equal to 1 over cosine squared minus 1 over sine squared. That's the same thing I have over here, and then you just kind of work it backwards. So then you would say, okay, I'm going to multiply that essentially by cosine, one side by cosine over cosine, one side by sine over sine, and away you go. Okay, so that's a perfectly legal thing to do. You play on both sides and go from there. 13. This is pretty straightforward. Again, I'm not going to do all of this, but I'll give you the push. The push would be cosine theta over sine theta plus sine theta over cosine theta. Find your common denominator. And then from there, after you simplify things, you should be able to find, put things into secant theta, cosecant theta. 15, okay, a couple different options here. Now, you've got this, and that would kind of lend itself to go through and potentially do conjugates, which would be nice to do. Left side's more complicated than the right side. Plus, I got that tangent thing going on. So if I multiply this by secant theta plus 1, secant theta plus 1, you can go through and do that. I would leave at this point the top alone in terms of trying to multiply this out. Now you got secant squared theta minus 1. The question is, what is that going to equal? Secant is 1 over cosine. So that means that this is all going to equal tangent squared theta. So when you do that, that kind of opens up things a little bit. I've got tangent theta times sine theta times secant theta plus 1 over tangent squared theta. Now, one of the tangents divides out. And then from there, again, remember, where are we trying to go? We are trying to get to, I'm going to write this just over here for 1 plus cosine theta. So we're going to try to multiply some of that out. What I would probably do then next is this, and again, there could be different ways of doing this. This is just the way I'm seeing it. Tangent you can write as cotangent, and the bottom is cotangent at the top, times sine theta times secant theta plus 1. So then I'm going to distribute that out. So then that's going to become cosine theta over sine theta times sine theta, and the secant will be turned into 1 over cosine theta. So in that case, now you've got, that's just going to turn into 1 because the cosines will divide out and the sines will divide out. And then I've got plus cotangent theta times sine theta. So again, sines go away, cosines go away. This cotangent we could have written as cosine theta over sine theta. Those go away, and then I'm left with 1 plus cosine theta. So that's one where you may not have an idea where you're going, but you do have an idea of what a first step is, and then you kind of fall into it, which is always a nice way to go. This one I would probably recommend, again, you've got 2 different fractions, so think common denominator. Before I do that, I would switch this to, I would change this to cosine theta over sine theta. Right? Then what do those simplify out into in terms of cotangent? And then you're pretty much done. Here, variety of different things. Conjugate would probably be your best move again. So multiply this by tangent theta minus cotangent theta. And then from there you should be able to mess around with some stuff. The tangent and the cotangents there you may need to turn into. So you'd get tangent theta minus cotangent theta over tangent squared theta minus cotangent squared theta. Now the thing is here, you could potentially turn the tangent squared and the cotangent squared into their Pythagorean identities of which they are related to. So like for example, tangent is sine over cosine, so then this would turn into secant squared minus 1 minus cotangent sine over cosine. So that's going to become cosecant squared minus 1. So we can get secant over cosecant, and that's what it that way. You could also, what else? You've got two terms. So, so that would equal tangent theta minus cotangent theta over secant squared minus cosecant squared theta. Those are the ones that will end up taking each other out. And so that would at least get you into sines and cosines. Oh, you know what? Sorry. It's a very big, complicated way of doing it. This would probably work even better. Sorry. Okay, I'm going to write this as 1 over sine theta over cosine theta plus cosine theta over sine theta. Now, from before, you know that this is going to turn into, you can find a common denominator. I believe we did this back as one of your other problems. That's going to turn into 1 over sine theta cosine theta. And then that's going to equal 1 times sine theta cosine, or 1 sine theta cosine theta over 1. So then you're done. That's a lot easier. So again, this step right here, going into here, we did this in an earlier problem. I know we did it on some example problems. You're just finding a common denominator there. And that will eventually turn into 1 over sine cosine. 21, common denominators here again. So start with this one. Oops. Slide that over. So common denominator-wise, that will cosine sine. So in this case, then you'd have sine. Common denominator is going to be sine theta cosine theta. And then you've got sine theta plus cosine theta. So now you have to get rid of the cosines, which presents an interesting problem. So, you could do this. You know what, this is, back up a second. Check this out. The tip off here is what is 1 over sine? Okay, that's cosecant. So if I break out 1 plus tangent theta over sine theta into 1 over sine theta plus tangent theta over sine theta. So this is going to now become cosecant. So we've got that part done. So then I'm going to end up with tangent's going to become sine over cosine times 1 over sine, which is the denominator. Those divide out. Now I've got cosecant theta, and this is going to turn into secant theta. Now we're done. Okay, so that should be enough to get you started. We'll do a couple more for tomorrow, and I'll see you in class.